For this problem, we're asked to factor, find the zeros, and then sketch a graph. So if we're going to factor it, we need to figure out which method we could use. I see three terms, so I'm thinking quadratic form. In this case, since the a value is 1, we can go directly into our two groups. We don't have to do the AC method. So to get x to the fourth, this would be an x squared, and then we need two numbers that multiply to 27 that add to negative 12. So in this case, that'd be a negative 3 and a negative 9. Okay, so there's the quadratic form. Now we have to analyze to see if either of these can be factored. This is not quite a difference of squares because the 3 is not a perfect square, but this would be a difference of squares. That can be rewritten as x plus 3, x minus 3. Now it's fully factored. We said this can't be factored, and these are both linear. So once we're linear, those are definitely finished being factored. Okay, so now we would get our solutions. Since this is a quadratic, we'll want to solve that out. So that means x squared equals 3, because again, we're setting each one equal to 0 and solving. So we'd add 3 over, then we'd square root both sides. We get positive and negative radical 3. And then from the other two factors, we would get x equals negative 3 and x equals positive 3. Now for the sake of graphing, the square root of 3 we'll want to estimate as about 1.7. That way we know where to plot it. Okay, so let's plot these points. We've got negative 3 and positive 3, and then 1.7 and negative 1.7. All right, we also know that the constant is the y-intercept. So we can plot that 27. Okay, now let's just check our end behavior, connect our dots, and see what happens. So I'm actually going to connect the dots first in this case, and then see if the natural end behavior matches what we expect. And the reason I can connect the dots first is I know I go through this point here, this 27. So if I start there, I know I've got to come down through this root 3, then up through this one, and that's the last intercept, so this would keep going up forever. Here, I'm going to come down through that intercept, then go up through this one and continue on up, because again, there were no more intercepts over here. So, let's see if that matches the algebraic end behavior. So this is a positively moving quadratic-like function. Again, we look at it like quadratic because it's even degree. So all even degree functions have the same type of end behavior. So positive and then up, like a quadratic. So our graph in this case matches what the algebra tells us, what the equation tells us.